Welcome to a new test and teardown video. Yes, you got it right. This is a DC power supply, a no-name kind of brand. I don't know if this is a brand or anything like that. It looks a little bit too nice to be homebrew. So it looks like it's a product or some kind of a company or something like that, but why didn't they add any names? I don't see any names anywhere at all. This is a, I don't know, 1960, 1970 kind of thing. I bet it's all transistors, so okay, it's maybe 1970. And we got some really weird switches here, so I think this is just meter scaling, but the meter just goes from 0 to 500, so you need to figure this out. And it's the same, whoops. It's the same with the voltage. This is probably also output scaling, not just the voltmeter scaling. 0 to 10 and 0 to 20. I hope it's not going to change the output range, so you're gonna, I don't know what's gonna happen here. I really like the colors. Green for minus and blue for positive. How about that? That's probably one of those auto fuses that pops if there is an overload, right? And that will be mains on off, I suppose. Again, it could be cool to know if it's on or off, up and down. No clue so far. Let's inspect the... No, there's nothing to inspect. I don't know. I've been looking a little bit through the holes here, and it looks a little bit like it's tube based, but that cannot be. That cannot be. It's very light. No, it is not so lightweight. I think I should open this before I power it up, because it's probably gonna take the fuses and everything bad. So how do I do that? Yeah. So yeah, that was not so difficult to open. I kind of only took off the rear plate, and then there's a little rectifier sitting there. Ooh, no, look at that. That is some leaked capacitors. Really, really bad. So yes, this is definitely something I need to handle before I can power it up. What about that? 70 to 80 volts? Really? And they are in series? Oh, what is going on here? I think I need to remove the more of the chassis. And also, this is built exactly as you would build tube equipment. So it is definitely from the time just after tubes. And I see all transistors all over the place. Ah, don't you just love it? Let's build with transistors, and we just keep the same methods and styles and all that kind of stuff. Yeah, we got two big transistors there. So yeah, what is going on here with the two capacitors here? I think what they're doing is, here's the rectifier, right? So there's this is the common, and then this is the first stage rectifier, and then a resistor, and then the second stage rectifier, right? And this is very, very typical for tube equipment. That is exactly how all tube equipment is designed. There's also one capacitor, resistor, or an inductor, and then the next capacitor, and they sometimes even do it 3 times. So yeah, this one is completely leaked, and that is the first one that got all the ripple currents. So of course this one is the one to leak first, right? But I think also, if we look a little bit careful, we can also see the other one was also leaked. This is a beautiful design. But I actually don't think this is homebrew. I think this is like a company made product, because you can also see the holes, how they are made. Absolutely perfect. This does not look like homebrew at all. But of course it is very, very old. If you have seen this design before, if you got any idea about brand or something like that, please comment. It's always funny to hear whatever people they know. But yeah, before I power this up, I definitely need to replace those capacitors. See, this is yes, this is the amp setting and the amp ranges. And here you go. We see some amp resistors in some plastic things. Isn't that just real cute? And that is the voltmeter settings, and definitely voltmeter calibration resistors. That is so cute. And here we got some transistors down there, probably germanium transistors. Quite a lot of transistors, by the way. And here's another diode and a trimmer for something. Oh, maybe this is a Cena diode and some reference adjustments and stuff like that. Well, that is a little bit interesting. But other than that, yeah, we don't see a whole lot of components to power transistors like that on a very big heatsink. And they are more or less in parallel. We got, yeah, the two collectors directly parallel, the two base parallel, and then different emitter resistors. Oh yeah, look, the two black emitter resistors, that's of course output. They go to two individual emitter resistors. So that is what this is for current sharing. Perfect. I love it. And that is the pre-driver. Yes, exactly like I expected. That is the output of this emitter follower. So this is the emitter, and then this one goes to the two base. Yeah, exactly. That is how it is. And yeah, there's not a lot to say about this. Other than that, I need to clean up the corrosion on the fuse. This is a classic thing. Always check for this. There is some sort of a special kind of nickel-plated metal stuff on those fuse sockets. They always corrode. I mean, anything else don't corrode because it's made of another alloy composition, but this is just always the fuse sockets. So this I need to fix. Definitely, look at that. Gross. And the main switch actually disconnects both of them. So I kind of like that. That is a good idea. Classic switch made in all those layers stacked together, and then, yeah, I mean, that is so classic. And what is that? Riophone 220. Yeah. So that is a gas indicator, neon bulb indicator on mains entry. And yes, I am looking on the mains connector. Otherwise I wouldn't touch stuff like this. I'm not completely lame. Okay, so we got 30 volts, and then what is that, 24 volts? I don't understand that exactly. Well, new capacitors, that is what we need to do. This is actually a little bit confusing. So here's the 2 ohm resistor removed, and the black wire here is actually negative from the rectifier that goes to the first capacitor, and then this 2 ohm resistor goes of course to the other negative side of the next capacitor. Positive just goes to the all 3 capacitors, and that's also the positive side of that one. So far so good, right? But then the positive from this one, That's 2 wires, and they're also red. How stupid and annoying is that? But they got a black wire here, and that is negative. That goes down to everything, right? But then there's also a black wire here. But that is positive. So that is positive going down in black. And negative go down here in red. Really? I'm not happy about that at all. This is how I'm gonna go and screw it up, and you can see here's positive. So this is why this little video clip here was super important for me to make, because I am definitely going to do this wrong if I didn't have this little clip. So here is my little repair job. All I did was finding 2 capacitors and stick them through the holes. I measured this one to be okay. I just cleaned it up. It's still nice and shiny, so I think we're gonna keep that one. And here I put in 2 new capacitors, and I think I got it all right with the positive is up here. Positive goes all the way. I really prefer if positive and negative go straight to that capacitor, and then we go to the next one. And then this is actually the negative output in red. Damn it. And of course you want those 2 capacitors, the 2 wires here from positive to go from that one, right? At the same point. You don't want to have them different places. Anyway, I think I am ready to power it up. Wish me luck. So I am ready to do the first power on, and I put both of those in the middle, 10, 10, and this is up. I don't know. Is it on or is it off? I don't know. Let's apply mains. And nothing bad happens. All right, let's... Uy. What happened here? 8 watts of idle. Okay, this pot is definitely totally dead. But it seems like it's working, right? So, yeah, okay. That pot needs fixing. So in the middle of the 20 volts, we got 9 volt. Okay. Okay, we can't. Okay, yes, we can go to 4 volts. Okay, 4 volts is also 4 volts, so that works. 4 and 6. Haha! It's already getting better. All we have to do is exercise the pots a little bit. And then what have we got here? Okay, I want to try and load it. But I'm really happy that this is only the meter. It doesn't really affect the output voltage, as you can see here on the meter. So far, so good. 7 watts of idle. That is not too bad. Let's load the thing. So this is on, is down. And then it's also important to see if a power supply is doing all sorts of weird power on, power down sequences. So here's what we're gonna do. We're gonna power this on and see what happens. That works perfectly fine. Goes straight to 6 volts. So that is good. I'm always scared with really old and funky transistor analog designs and stuff. So I am ready with a little bit of load. Let's crank it out. On 6 volts is fine. And that will be 500 milliamps full. So let's turn on 100 milliamps. Wow, it's accurate. 100 milliamps. Let's turn on and off the 100 milliamps and see if that affects the output voltage setting. Obviously, this doesn't contain op amps and super local sensing and all that kind of stuff. So, but look at that. That is not bad at all. Okay, so this is 100 milliamps. Let's play a little bit. 2, 3, 4, Okay, let's keep it at 400 and then see what happens when I play with the... Oh! What? Hello? So it's a foldback, right? So I turn off the... Oops! What happened? So I need to... Oh! It's a foldback! How sexy! And this is of course to prevent it from overheating. Wow! That is cool. I didn't know that. Okay, so this is just... this is not a thermal switch or anything like that. This is the research for a foldback. Look at that. If you didn't see that, I crank it up 400 milliamps, then dial down the current setting, and then look at the voltmeter as well. Oops. So that is exactly the point of 400 milliamps. Now I'm going to turn off the load, turn down the load to 0, turn on again. Okay, now I'm going to do the opposite. Instead of dialing the current, I'm going to adjust 100, 200, 300, and then we know that we have set this for about 400, right? So 310, 20, 40, 50, 60, 70, 80. Oop, you see? It definitely works. Foldback, that is what we got. That is quite nice. You don't see that very often, especially not on funky transistor stuff like that. Let me turn off the load. Okay. Nice. And then overload. I mean, 20 volts. See, it's actually already perfectly fine and stable. That pot meter only needed a little bit of exercise. So full power here is 19.6. I am actually quite happy about this. So let's give it full output voltage, full current, 1 amp full. We are now loading 300 milliamps. Wow, that also goes accurate. And let's crank it up to 500. So this is 50% load. And then look what I'm doing now. I'm gonna go to AC ripple. Oi, 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 oi. That is 0. That is nice. So my output power is 9.7 watts and the power consumption from the mains is 28 watts. That means the rest goes straight to that one and that one. Wow. Let's crank it all the way up. Can it do 1 amp? Yes, it can do. That is 1 amp. Oh, and then we got 34 millivolts of ripple. Let's go down. 900, 800, 700, and okay, so the ripple starts at 700, 800. Okay, yes, okay. So this is where the ripple starts, and I think it has something to do with the output voltage. So what if I turn down the output voltage a little bit? No? Yeah! Let's go a little bit down. And then ripple goes down, of course. I think the ripple is below the threshold of that meter. Yeah. See? $40 watts of mains, and I use 15 watts. Let's give it 1 amp. So this is 19 watts of output, 46 watts of input. And I don't really see anything getting one more. Yeah, okay, that one. Oy, oy, oy. The power resistor there gets one. But those serious transistors, they are nice and cold because this is a very, very big heat sink. But wow, we fixed this really funny looking power supply. So that means I got nothing more to add to this video. All I want to say is thank you very much for watching, and see you very soon again. Bye bye.